one of the things that we see more and more is trying to validate that you're actually talking to your loved one. So generative AI has opened up a real issue with authenticity. Something happened at a certain time in a certain location. That can go a long way towards reducing the spread of misinformation, to improving our understanding of the world. I mean, being able to provide some assurance that, no, this actually did happen, I think goes a long way towards helping the world maintain open and honest communications.
All right, next question from Fulgiori. Can Space Network connect to IoT devices?
Yep, actually, that's a good question. And I would say that's where we're starting, actually. So IoT devices are supported under the 3GPP roadmap. They're actually the first devices that are supported by the 5G non-terrestrial network standards that were described in Release 17. And so that is actually where a lot of our initial testing for these systems will be, is using NB-IoT.
Yeah, so we're starting with NB-IoT. That doesn't mean we're limited just IoT devices, IoT communications. So perhaps you can talk about some of the other communications or demonstrations we'll be doing with CTC-1.
Yeah, indeed. So there's a bunch of things that we're going to be doing with this mission. We start with the NB-IoT because that's a well-defined standard. There's hardware that's already been built, right? So Qualcomm, Sony, and MediaTek and others have built modems that support these technologies. And so it's a good way for us to get started on testing with commercially available real-world hardware that anybody can go out and get. The challenge comes that, the standards institutes like 3GPP have outlined, what 5G advanced looks like, what 6G looks like, and the standards and the types of protocols that will be necessary for those communications. The issue is we don't have the hardware yet, right? So a lot of the hardware that supports these new radio protocols is just beginning to kind of emerge into the market space. Most of it's in, let's say, the R&D space, so it's not ready for commercial prime time, but it's available for testing and protocol development. And so that's also what we'll be doing with CTC-1, is that we'll be moving into evaluating 5G new radio, which is part of the 5G advanced family of standards, and then moving into 6G eventually. That will, pave the way for, let's say, real-time communications of a direct device type of network. So it's a stepwise process. There's a lot of pieces we have to learn along the way. And I think one of the nice things because we want to build this as an open system and we really want to foster cooperation, we'll be sharing a lot of the data that we get from our field trials with the larger community so that other folks from, just backyard enthusiasts to telcos can take that data and use it to understand what kinds of service they may wish to bring to the world. And again, push that innovation cycle, because I think that we've all become very used to waiting for the big risks to be taken by major leading companies like Intel, AMD, NVIDIA. And that's great because they have tremendously deep know-how. If we think about sort of what's happened in the tinkerer space, in the maker space, where we've got people taking Atmel hardware, Arduinos and things like that, and beginning to push new concepts for communications. I always think about Meshtastic as a community-based communications protocol. And I see that kind of innovation using what's available as off-the-shelf hardware as a big inspiration for what we may be able to bring into the market space. But again, it depends on using what's out there and what's commercially available. So, it's our hope that by sharing the data as we get it, sharing the lessons learned with the larger community, we can help foster more of that innovation and really grow an ecosystem, a global ecosystem of space cadets who want to help improve communications for their communities and not just for, profit.
And do you want to talk a little bit about the satellite's capabilities? So we can talk a bit about the inter-satellite links and what we're doing testing. For example, we're talking about the handover testing and then talk about the types of data transfer that we wish to see with these satellites, be it, SMS, data messages on WhatsApp, voice calls, and so on and so forth.
So the satellites themselves are still very much research and development satellites. But we'll primarily be operating over S-band for the terrestrial to non-terrestrial communications. So satellite to ground will be over S-band. For those that are interested, it's the N256 band, which is supported by a good number of modems out there. You can find them if you dig around a little bit on DigiKey or your favorite supplier. And then the ISL, the inter-satellite links, is over Ka. So Ka is a much higher frequency band. It's the same bands that Starlink and others use for communication. So we have to be careful not to interfere with them when we're doing our tests. But the inter-satellite link, what it does primarily is it allows us to extend the range of coverage. So it allows us, if we have a gateway station in one location, we can extend the range of coverage that gateway station can reach by using the satellites as a relay. So in a similar way to like repeaters in ham radio networks, it allows us to sort of bounce the signal along. Obviously, you pay a price for that with latency, but it does allow for extension of range. The other side of that is that it allows you to have a longer conversation, let's say. So if you and I are having a WhatsApp call via one of our satellites, a satellite in low Earth orbit will go from horizon to horizon, depending on its elevation, in 10 minutes or so. So that's kind of a problem if you and I are trying to have an hours-long conversation. Because we have multiple satellites, as one begins to set, another one will pick up where it leaves off. So this provides continuous coverage. But as you can imagine, coordinating that handover is a bit tricky. And there's fortunately a lot of good work that's been done in terms of setting up those protocols and making that technology happen. But it's one thing to do it in a laboratory or in a simulated environment. It's a very different thing to do it when you're actually on orbit and you've got to navigate all sorts of other types of issues like interference on the ground, interference in the sky, trying to be a good neighbor in spectrum and not interfere with somebody else. And so, and not to mention weather. Weather tends to interrupt radio signals sometimes. So managing all of those pieces takes some time and it takes some testing. And that's another place where we're excited to be able to share with the larger community is as we do these tests and we begin to generate data from this, we'll be able to share that with others so that they can also work on improving these protocols.
And the type of, some of the things we're hoping to demonstrate with these satellites. So we should be able to send SMS messages over data, WhatsApp style data messages, voice calls over data, internet browsing, financial transactions, these types of activities. We won't be with CTC-1, we won't be able to support high data throughput such as streaming, Netflix, download a 4K film. But again, that's not our initial use case anymore. Our initial use case is bringing connectivity to communities and regions which are underconnected or unconnected and underserved, where the ability to access the internet or to have a voice call or send messages it's a game changer in terms of bringing people into the online world, being able to access educational resources or economic opportunity or healthcare and so on and so forth. So that's very much our starting point with this.
Yeah, indeed. I think it's important to understand that at the end of the day, whether it's a financial transaction or an SMS message or an 8K streaming video, it all comes down to data. Right. So what's most important for us right now, and the piece we really want to work on initially here, is making sure that we can move data reliably, we can move data resiliently, right? So that we have the opportunity to always repair the network, as data is in transit, that we transmit that data securely, and that the users and the owners of that data have total control over where their data is going, how it's getting there. And I think that that's something that independent of sort of scaling up to larger and larger swaths of data, I think having those pieces, those cornerstones, if you will, of the foundation really set and ready for an open cooperative architecture is something that is going to pay dividend a long, long ways into the future. Because if we look at just the evolution of computer hardware, right, and go back to the 90s or to the 80s, kinds of compute power that we had on our desktop was paltry compared to what we have now, walking around in our pockets. So I think that kind of bandwidth expansion and processing capability expansion will just happen naturally as a course of the process of improving technology. I think the piece that really needs to be focused on, and that's the place where we're putting our attention right now, and we're really testing out with this first mission, CTC-1, is how do we cooperate satellites? How do we make sure that those fundamental aspects that underpin a decentralized network really, really work and work in a way that is unbreakable, right?
Next question is from Keezy_2 or 02. Can Spacecoin satellites, I guess the protocol, if I reinterpret this as well, support other decentralized proof of storage layers beyond connectivity? So I guess, can satellites be used to transmit data, which is not just connectivity data, but for compute, storage, files, other things?
Yeah, indeed. There's a lot of flexibility in what we can transmit. In many ways, the satellites, like any other node in a network, and what kind of data is being transmitted is not really of a concern. Obviously, you need to be able to move the file or the stream of data. So if you want to send a very large file, you're going to have to utilize a number of satellites, and you need, to have good view of those. So there's a lot of ways that we can address larger file transfers and things like that. But we're essentially file type agnostic. So long as the users have authenticated onto the network, they can pretty much move whatever they want.
Yeah, and I think that's one of the use cases or the visions that we're excited about, is building this mesh network in space where if you have a satellite which is, let's say, involved in compute or storage, there's lots of talk around data centers in space and things along those lines. All of those other satellites will have to transport that data around or through space around the world to downlink it and uplink it in real time where people need that data. And that either means that they are going to have to build out that global infrastructure themselves, which is incredibly expensive if you have, let's say, a point solution such as a data center, or you're providing imaging solution, or you will make use of let's say, a relay mesh, such as ourselves, or there's some other space startups who are looking to play in this space as well. And we believe that actually having a decentralized space mesh, for want of a better word, will be the better choice, because by nature of being a decentralized network and DeepIn and how a DeepIn system should function is that cost base is shared, so the network grows quicker and therefore has more resource, and therefore you can provide your service cheaper, and you end up in this virtuous flywheel. So that's definitely something which we are going to be paying close attention to and focusing on as well.
I think that's one of the exciting things about this time, right? There's a lot of activity and there's a lot of interest in building decentralized systems and really trying to understand and tackle the many different challenges that come up when you attempt to do that. So, I think it's a key piece of our vision, right, is to provide cornerstone or that base for the ecosystem to evolve, similar to how Android and other types of open architecture programs and projects have grown, being able to say, okay, here's some operability standards, go wild. As long as you, stay within these bounds here, you can use the whole space to do what you want. And I think that's something that classically has not been available for satellite communications. I mean, prior to what we're working on, AMSAT, the amateur satellite radio system, was really the only other non-terrestrial system that at least I know of that would allow users to use satellite communications in their communications methods. And so this is an interesting moment where we can partner with a lot of different folks. And I'm really excited to see who else is out there and what projects they're working on, and to find out how we can begin to bring those into the space.
Yeah, and I think it's very much the view that we don't want to dictate what people do with the network. We want to sort of let 1,000 flowers bloom. And in the same way that when Apple launched the App Store, they didn't know the type of apps that people would develop and launch. And similar thing for us, we want to build this protocol and build a community and evangelize what we're working upon and have other people come up with use cases and ideas. And so we've already had people talk to us about wanting to do, for example, messaging apps which never touch terrestrial infrastructure. So it's fully in space, much easier to secure. You can have end-to-end encrypted, secure. We have people who want to use it for crypto transactions. We have people who are interested in using it for cybersecurity purposes. And actually, perhaps, Adam, you can say a few words about a patent that we have been granted, which is around using satellites to determine or to prove your location and how that can be used to enhance security, and particularly in a world which is full of increasing number of bad actors and hacks and so on and so forth.
Yeah, indeed. And I think, an exciting application that comes out of satellite communications, because it's hard to tamper with the location of a satellite. It's pretty well known to a lot of people. In fact, all of us who are operating satellites are constantly telling each other, hey, here, my satellite's going to be here. Here's some updated information on it, because we don't want to crash into each other. But a benefit of that is, of course, then we know to a very high degree degree where those satellites are. And so we can turn around and offer a service to folks who utilize the network. And that is that proof of location component. And there are simple ways that it can be deployed, right? So for example, I can say I only want to allow the initiation of a crypto trade to occur from my office. So I can utilize, and there are some products out there on the market that do this, so I can geofence, if you will, a location. That means that only certain locations around the world are allowed to initiate or receive data transfer. So I think that's a big place, but it gets far more interesting when you sort of open up the question around, well, what does it mean to be able to prove that someone is somewhere? And if you think about like assets moving around, so asset tracking, for example, is a big thing. International shipping, the old adage, where's my stuff? And, FedEx may tell you, oh, it's over here, and it's not. I've had that problem a few times. So being able to track your assets in real time, but beyond that, let's say something happens to that shipping container. Let's say something happens to that asset. And now you're in an issue where, well, how do you know it was where it was? So insurance comes in, and being able to provide proof, right? So cryptographically signed proof that at this date, at this time, this piece of asset was at this location. That has a lot of impact and a lot of potential for revolutionizing not just international trade and shipping, but also communications. I think all of us get it, right? We get a lot of these robocalls and spam calls that are spoofing. What might it mean to have it be something in the future that the device initiating the call has to accurately report its location? So being able to create secured networks whereby your telephone number is secured against spoofing. I think that begins to open up a lot of possibilities, not just from an ordinary nuisance kind of standpoint, but also from, the ability to do secure banking, to securely transmit data. I mean, I think one of the things that we see more and more is trying to validate that you're actually talking to your loved one. So generative AI has opened up a real issue with authenticity. How do we know what we know? How do we see something and say, oh yeah, that actually happened? And, having a system that can provide data real time that proves that something happened at a certain time in a certain location, that can go a long way towards reducing the spread of misinformation, to improving our understanding of the world. I mean, there have been a lot of really horrendous things that the world has witnessed in the past months alone. And I think there is a healthy skepticism that is growing within the populace of like, is that real? Is it real or is it AI? And being able to provide some assurance that no, this actually did happen, I think goes a long way towards helping the world maintain open and honest communications.
And talk about the future. Do you want to say a little bit about where we're going in terms of optical communication? People may have been reading recently a lot about Starlink buying spectrum from EchoStar and how there might be, we've mentioned a couple of times in this call, that we have to be wary about interference. And so maybe you can talk about how we transmit today as an industry in terms of radio frequency and what that will look like in future once we move to optical comms, and what the benefits will be for people with that.
So the electromagnetic spectrum, right, which is all the waves, all the radio waves live on the electromagnetic spectrum, and we have to share. Because of the nature of radio, it spreads out quite a bit in an environment. That's why whenever you look on a cell phone or a Wi-Fi device, you'll always see some sort of FCC or European Union mark, a CE mark, because there's a need to register devices and register which bands, which frequencies they're going to operate on, so that we can have assurance that those devices won't interfere with each other. I think it's pretty well known that, pilots, for example, will have an issue at airports where one will be communicating and then somebody else will step on the mic and block that communication. And there have been a couple of unfortunate incidents where that's actually resulted in the loss of life. So radio interference is a real problem. And in telecommunications, there's quite a lengthy, expensive, and slow process for licensing spectrum. And there's a lot of burden in terms of cooperation that has to happen between different operators to make sure that everyone can make their phone calls, everyone can get their data pushed through over the air because of radio. Optical comms are also part of the electromagnetic spectrum, but they're just happening at a much, much higher frequency. And one of the things that's nice about optical systems is that when you use something like a laser, you can actually narrow the beam significantly so that now you can send comms in a way that doesn't interfere with other receivers, transceivers in the environment. So there's sort of this understanding that, okay, if we can switch from radio to light, we can pick up a lot of bandwidth. But there are a lot of challenges with optical systems. The other benefit with optical systems is you can put a lot more data through an optical link than you can through a radio link. So a good analogy is to think about the leap in speed that we saw with the internet when we went from analog, digital, copper systems, right? So analog, old dial-up for those of us that were around in the 80s, to DSL in the 90s and early 2000s. And that was all on copper. So that was all kind of like radio, right? It was limited by the wavelength. It was limited by certain physical aspects of the system. And then we switched over to fiber optic systems. And suddenly 100 megabit, 150 megabit, gigabit speeds became a reality. And similarly, that's something that we'll see with optical comms on satellites, is the ability to support much higher data rates. So like when I was saying that it will naturally just kind of happen, that throughput will increase with time. That's why, because optical systems are becoming more compact. They're beginning to work out the challenges around how do you point an optical beam? How do you steer an optical beam so that you maintain link between satellites, right? They're moving around in space. So it's not just like pointing point to point. You really need to be tracking as you're pointing. But there are some other benefits to optical systems. And I think one of the biggest ones, of course, is power. So optical systems use significantly less power than radio systems, which means so I have the ability now to more efficiently transmit data. And so there is a big shift towards optical systems for satellite communications, especially for satellite to satellite communications, because you're up in space. You don't have to worry about blinding anyone with your laser, and you don't have problems like with weather and things like that interfering with the optical beam. But, you've got a lot of management to do. Starlink is doing tens of thousands of optical interconnects every day. So, those satellites are flying around and they're linking to each other, and then they're transmitting data, and then they're breaking that link, and then they're looking for another satellite and making that link. So it's a very dynamic environment, and it's very different than a radio, right? Because a radio beacon spreads out very nicely. Even if you use a parabolic dish and you focus it down, you're still illuminating a few degrees of sky with that radio dish. So there's a huge area that's being lit up with a radio. So that's why that coordination is really important. And when you switch to optical, you lose some of that constraint. But now you're pointing a very, very small beam, which means you have to have very high accuracy in how you point. So there's always a bit of a trade-off. But optical's coming in. I think we'll see more and more optical satellite links. I know that there's a number of companies that are working on optical ground stations for very large file transfers. And of course, they're welcome to join Space Network and adopt the protocols, because we'd love to have those capabilities in the network as well. But, again, this is all very nascent technology. And, back when I was doing my PhD, some of the techniques would require these massive tables that could be, a meter by 3 meters in size and weigh, several thousand kilograms and have millions of dollars of optical components on them to do some technique like imaging or transmitting very high speed data. And those same systems are now fitting on a chip. So on a photonic integrated chip. So I do think that we're going to see in a very near term the rise of optical terminals and an improvement in the amount of data that we can transmit over satellites. So we're part of that community. We're working with some great people on developing some of that tech. So there'll be more to say about that, hopefully in the near future. It's an exciting time.
Good. So I think on that note, it's been roughly an hour. So I think we'll probably wrap up there. So thank you, Adam, for your time. And thank you to everyone who sent in their questions. We really appreciate you engaging with us, and we hope that you continue to do so. For those of you who don't follow us yet, please come find us on Twitter, or X, as it is now called, and our handle there is Spacecoin. You can also go to our website spacecoin.org, so you can sign up to our newsletter and follow along, and you can join various Telegram groups or Discord channels that we participate in. Please do make sure any group that you participate in is actually run and managed by us. There are other groups out there pretending to be us, so please just be careful with who you engage with. And to wrap up, so we've got 1 satellite live. We're launching 3 more within the next month. As it currently stands, we'll have 3 more satellites live and a lot more happening. So stay tuned. Thanks very much. And we're excited for the next step in our journey.
Yeah, thanks, Stuart. It was great chatting, and let's do it again sometime.